Hello, ladies and gentlemen. My name is Mrs. Taylor, and today we are working on our summer math module, solving systems of linear equations and linear inequalities. By the end of today's video, you'll be able to find the solution to a system of linear equations using all three of our methods, and you'll be able to show the solution set for a system of inequalities. First, I need to remind you, what is a system of equations? Well, a system of equations is two equations with two variables. In fact, you can have two or more equations in two or more variables, but you'd have to have at least two, and yeah, that's a good place to start. When we talk about the solution for a system of equations, what we're looking for is the ordered pair where the two lines intersect. So I'm gonna come in here and draw a line, and it's gonna be terrible because I'm just winging it. Also, I'm not gonna use a highlighter. So I would be looking for the solution of that line and this line, and where they intersect. Looks like this point right here, and I didn't use a ruler, and I'm never ever going to find an actual solution for a system of equations by graphing without using a ruler. But this point right here is where those two lines intersect. The answer can be represented as an ordered pair. The solution to a system of equations is the one value of x and the one value of y that satisfies both equations. Now listen, this one line right here has all kinds of solutions to it. Every point on this line is a solution to that line. Every point on this line is a solution for that line, but this one right here, that is the solution for the system of equations. It's the one x, the one y that works for both equations. And we know of three methods for solving systems of equations. First, we're going to remind ourselves how to solve by graphing, and then by substitution, and then by elimination. Um, each one of these methods has its advantages. The advantage of solving by graphing is it's the easiest one for us to visualize what it is when we find the system or the solution to a system of equations. So let's see. Let's remind you of some stuff. Both of these equations are in slope-intercept form. Y equals mx plus b. And reminder, m is your slope, and that is rise over run, and B is your y-intercept, or where the line crosses this y-axis. So looking at this top line, we have, or this top equation, we have y equals negative x minus 2. I'm going to start at my y-intercept. My b is negative 2, so I'm going to come down here and put a point on negative 2. And my slope is the coefficient of x. Well, it kind of looks like I don't have a coefficient of x. There's just a negative sign. But if there's no slope written, it's going to be 1. In this case, my slope is negative 1. Whenever I have a whole number as a slope, I can put it over 1, because negative 1 divided by 1 is just negative 1. So this allows me to have both a rise and a run, which is important for graphing my line. So starting at my y-intercept, I'm going to do my rise and then my run. My rise is negative 1, so I'm going to go down 1 and to the right 1. And when I graph, I'm going to put a couple of different points just to help me line up my ruler correctly. And it's worth it to me to remind you that negative 1 divided by positive 1 would give me negative 1. And that's the same thing as positive 1 divided by negative 1. So it doesn't matter if I have this negative sign in the top or the bottom, the answer is still going to be negative 1. And the reason why I say this is now I can have a rise of positive 1 and a run of negative 1. So I'm going to go up 1 and to the left 1. So starting back here, I can go up 1 to the left, and I can just put some points in here just to help me line up my ruler. All right, when we graph lines, we always draw our line from edge to edge. We put arrowheads on both ends of the line, and we always, always, always use a straight edge. Now, maybe you don't have a ruler handy, but I'll bet you that you have a student ID handy, an ATM card handy, or even just, I don't know, a baseball card. Um, Anything will work. And hopefully you noticed when you started working on this module that you can print out a sheet of paper that has all the problems that we're going to do today in this video. And the one really important aspect of it is it has a blank graph for one of the problems you're going to do on the quiz, which will be very helpful. Okay, so this is my top line. I'm going to put a blue dot here to remind me that that's that one. And we're going to do the bottom line, which is y is equal to x minus 4. So my y-intercept is negative 4. I'm going to come put a point here. And my slope is the coefficient of x. Well, there's no coefficient written, so my slope is positive 1. If I have a whole number, I can put it over top of 1. So I have a slope of 1 over 1. Rise 1 to the right. So up 1 to the right 1, up 1 to the right 1. I'm going to put a couple of points on here to help me line up my ruler accurately. All right. And this is going to be persnickety. I need to slide this down a little bit. Okay. It's important to use a straight edge when we graph systems of equations because it's we need to know that we're being accurate with our graphing to know what the solution set is. So I have graphed this bottom line, this y equals x minus 4, and where do these two lines intersect? They intersect right here. Our answer is always an ordered pair, so parentheses x comma y, close up your parentheses, and just a reminder, our x is we're starting at the origin, we're going left or right, so I'm going to the right 1, and I'm going down 1, 2, 3. So 1 comma negative 3. Especially with graphing, it's important to check your answer because it would be very easy to graph slightly inaccurately and not quite know for certain that our answer is really the right answer. So I'm going to take this value of x and this value of y, and I'm going to plug it into the top equation. So y is negative 3 equals negative x. So negative, and then x is 1 minus 2. All right, so negative 3 equals negative 1 minus 2. Negative 3 equals negative 3. Yes, that's true. All right, I'm going to look at the bottom equation. I'm going to plug in x is 1 and y is negative 3. So I'm going to do negative 3 is equal to x is 1 minus 4. Negative 3 is equal to 1 minus 4 is negative 3. So I know for certain that this is my right answer. We junk that up by writing all kinds of stuff, but I know for certain that my answer is 1 comma negative 3, and it has to be written as an ordered pair. All right, moving right along. Solving by graphing is great because it helps us visualize what it is that we're finding. We're finding that one ordered pair that works for both equations, but it's not always practical. We may not have easily graphed lines. We may not have lines in slope-intercept form. We might not have equations where the graph crosses at a nice pretty number like -2 or -4. How would we accurately graph if our y-intercept was negative 1.666 repeating? So it's not always the best way. All right, so we're going to solve the system by substitution. Now this works. It doesn't matter if it's x or y. I need to get that out there. But if we have one variable that has a coefficient of 1, meaning no number written in front of it, we can get that variable by itself and then substitute it in to the other equation. So looking at these two equations, let's talk about coefficients. The coefficient for this x is -1. Maybe. The coefficient of y is 5. Nope. The coefficient of x is 3. Nope. The coefficient of y is 1. So I've got y all by itself. I am going to get this y by itself, and then I'm going to substitute whatever that value is into this top equation. So let's see. I'm going to rewrite 3x plus y is equal to 16, and I am going to get y by itself by subtracting 3x from both sides. So this gives me y is equal to negative 3x plus 16. All right, I worked with the bottom equation. So I am going to take this value of y and I'm going to plug it into the top equation for y. Okay, so what does that mean? I'm going to start with writing the equation, negative x plus 5. But when I get to that y, I'm not going to write y. I am going to write this value of y from the other equation. So negative 3x plus 6, close that up, and then I'm going to go back to writing the original equation. So I took out the y, I'm going to pick up right here equals 0. All right, So now you can see I've got one equation in one variable, and that is a piece of cake, ladies and gentlemen. You can do that. So I'm going to bring down this negative x, and I'm going to take this 5, and I'm going to distribute it into the set of parentheses. So 5 times negative 3x gives me negative 15x. 5 times positive 6, that is supposed to be a 16, ladies and gentlemen. I'm glad that I caught that. All right, so I'm sorry, 5 times 16 is positive 80 equals 0. All right, at this point, we're going to combine like terms. Negative x minus 15x gives me negative 16x plus 80 equals 0. My goal at this point is to get the variable on one side of the equal sign and the number on the other side of the equal sign. It doesn't matter which one of these I move, but if I move this 16 to the other side, it's going to become positive, and I love positive numbers. We have a much better chance of, uh, oh no, much better chance of being accurate and correct if we work with positive numbers. Negative 16x plus 16x is 0. So on the left-hand side, I've got 80. 0 plus 16x is 16x. Trying to get x by itself, I'm going to divide both sides by 16, and this gives me x is equal to 5. My answer is going to be an ordered pair, and I just figured out that 5 is my x value, but I have to figure out what my y value is. Here's the thing. I can plug this value of x in to this equation, or even this equation. And I like us to think critically about what's going to be the easiest, because easy tends to mean we're going to get the right answer. Well, of all of these, this one is going to be the easiest one for me to work with. Why? Because I'm trying to figure out what y is. So all I have to do is plug in and do some basic arithmetic. I don't have to do algebra at all. I don't need to move things around to the other side of the equal sign. Just plug it in and do the arithmetic. Okay, so I am going to say y is equal to negative 3. We figured out that x was 5, so I'm going to plug in 5 for x plus 16. Y is equal to negative 15 plus 16, so y is equal to 1. All right, can I check my answer? 100% I can. In fact, I do believe that I will, because I believe that checking is just a great way to only have to take this quiz once. All right, so I'm going to plug in 5 for my x value and 1 for my y value. So starting with the top equation, I'm going to have, this is my checking area over here. I'm going to plug in negative 5 plus 5 times 1 equals 0. Well, negative 5 plus positive 5 equals 0. Yep, true story. Working on the second one, 3 times 5, oopsie, plus 1 is equal to 16. 3 times 5 is 15, plus 1 equals 16. Yes, so I know that this is the right answer. All right, let's move on. So just to recap, the graphing, great when I have a graph, when I have lines in slope-intercept form. If I don't have one of the lines in slope-intercept form, when I don't have a graph, but one of my variables has a coefficient of 1, substitution is nice, quick, easy. Elimination is the one that always works. It may not always be the easiest thing to do, because sometimes these can get kind of hairy, but it always works. Okay, so my goal for elimination is to get the variables, pick either x or y, doesn't matter. I want to get my coefficients to be the same number but opposite signs for one of my coefficients. So I see already that my x's have one positive and one negative. So I like that. Also, I notice that 3 and 6 have a connection. If I double 3, that's going to give me 6. So what I'm going to do is I'm going to multiply this entire top equation by 2, okay? So 2 times 3x is 6x. 2 times negative 2y is negative 4y. And 2 times negative 11 is negative 22. Don't forget, you have to do everything, both sides of the equal sign. All right, I'm going to rewrite this negative 6x minus 10y equals 8. Remember, our goal was to get one variable to have the same number but opposite signs. I got one positive, one negative. This is exactly what I wanted. And the reason why I want to do this is I want to eliminate one of the variables by adding these two equations together. So I'm going to draw a big addition bar across here, and I am going to add straight down each one of these columns. 6x plus negative 6x is 0x, which is 0. Negative 4y minus 10y is negative 14y. I'm going to bring down my equal sign. Negative 22 plus 8 is negative 14. Trying to get y by itself, so I'm going to divide both sides by negative 14. Negative 14 divided by negative 14 is 1. So on the left side, I've just got y. And on the right side, negative 14 divided by negative 14 is positive 1. So my final answer is going to be some ordered pair, and I just figured out that the y value is 1. All right, at this point, I can plug this value of y equals 1 into the top equation, the bottom equation, or either one of these. But I'll tell you what, I'm never going to pick one of these because I've already made it more difficult by multiplying. So I'm probably going to choose one of these. I can choose the top or the bottom. I'm going to choose the bottom equation. And my reasoning is just because 8 is positive. So that's all there is to it. Like that's my thought process. So negative 6x minus 10 times 1, because we figured out that y is equal to 1, equals 8. All right, so that gives us negative 6x minus 10 equals 8. I kind of lied. I knew that this was going to be negative, and I'm going to add 10 to both sides, and I do like my positive numbers better. All right, so negative 6x is equal to 18. I have to divide both sides by negative 6. Pay attention to your signs. Negative 6 divided by negative 6 is 1. So on the left side, I'm left with x. 18 divided by negative 6 is negative 3. So my final value of x is negative 3, which I'm going to plug into my ordered pair. So I have negative 3 comma 1. Can I check this? Absolutely. 3 times negative 3 is negative 9. Minus 2 times 1 is negative 2. Negative 9 minus 2 is negative 11. That worked. Negative 6 times negative 3 is positive 18. 10, negative 10 times positive 1 is negative 10. So 18 minus 10 is 8. That worked. I know for certain that this is the right answer. Okay, moving right along. Now, this is when things get super hairy, but this is a very common thing that we're going to have to do. So again, our goal is to eliminate one of the variables by getting the coefficient to be the same number for both equations, but opposite signs. I have positive and negative, so that doesn't really help me figure things out. Um, let's see, 6, 12, 18, 24, 30. I'm just thinking about the multiples of 6, and then the multiples of 3 are 4, 8, 12. There it is. That's what I'm looking for. See how both of these go into 12? So I would need to multiply my top equation by 2 to make this 6 get to a 12. So I'm going to multiply my top equation by 2, and I'm going to multiply my bottom equation by 3. But one of these has to be positive and one of these has to be negative. So I have to think about which one do I want to put the negative sign with. It could be either one, truthfully, but I'm going to think strategically about how I want to do this. I think I'm going to put my negative sign on the top equation just because this is going to turn positive, and anything times 0 is 0, which makes life a little bit easier. Okay, so let's distribute this negative 2 to everything, this entire top equation. So that's going to become negative 12x plus 10y is equal to negative 2 times 0 is 0. All right, working on the bottom equation, I'm going to multiply the entire bottom equation by 3. 3 times 4x is 12x. 3 times negative 4y is negative 12y. 3 times 4 is 12. Excuse me, I'm sorry. I'm going to draw my addition bar, and I'm going to add straight down each one of these columns. Negative 12x plus 12x is 0. Don't need to write that. 10y minus 12y gives me negative 2y. 0 plus 12 is 12. I'm trying to get y by itself, so I'm going to divide both sides by negative 2. Watch your signs. Negative 2 divided by negative 2 is 1. So on the left side, I'm left with y. 12 divided by negative 2 is negative 6. My final answer is going to be an ordered pair. So I have something, comma, negative 6. Okay, I need to plug negative 6 into one of these equations. I can choose the top, the bottom, or either one of these, but I'm never, ever, ever going to choose one of those because if I multiplied them, they just got big. So I don't want to deal with that. Okay, so I think because the 0, I'm going to plug it into the top again. So I'm going to say 6x minus 5 times negative 6 is equal to 0. 6x plus 30 equals 0. I'm going to subtract 30 from both sides. 6x equals negative 30. Divide both sides by 6. Negative 30 divided by positive 6 gives me negative 5. Watch your signs. So my final answer is negative 5 comma negative 6. Do I feel a little bit hinky about this? I do. You know what I'm going to do to not feel hinky? I'm going to check my answer. All right, so let's see. 6 times negative 5 minus 5 times negative 6 equals 0. 6 times negative 5, negative 30. Negative 5 times negative 6 is positive 30 equals 0. Yep, that's true. All right, 4 times negative 5 minus 4 times negative 6 is equal to 4. That's a lot of 4s. 4 times negative 5 is negative 20. Negative 4 times negative 6 is positive 24 equals 4. Negative 20 plus 24. All right. I feel 100% confident that my answer is correct. Okay, so we have solved by graphing, easy peasy, but you need a graph. Solved by substitution, great if you have one of your variables that has a coefficient of 1. And then we solved our system using elimination. We might have to multiply one equation or both equations. Every once in a while you get really lucky and you could end up having something like um, 2x minus 3y equals 22. I'm just making stuff up here. And 4x plus 3y is equal to negative 7. And you get really lucky because in this kind of problem, you don't have to multiply anything. You can just add straight down and the y's would go away. And the fact that the y's go away is why this method is called elimination. We are eliminating one of the variables. Okay, so let's move on to our system of inequalities. Very, very similar, except for our solution set isn't one ordered pair. It's going to be so many solutions that we can't even write down the ordered pairs. So our answer set has to be represented graphically. So I'm gonna throw up a line here, and it's gonna be this one, and I'm going to do this one, and we would choose some test points, and we would decide that ultimately our answer, our solution set, are all these points over here. Okay, so that's what we're looking for. We want to graph both of our lines. We're going to choose a test point for both lines, and then we're going to shade in the only part of the graph that has answers that work for both lines. One of the things that I want to point out is no matter what, well, I don't want to say no matter what, but typically when you have two lines that intersect, I'm parsing my words here. Let's see. If I have two lines that intersect, I will always have four regions that are created, and the solution set will always only be one of those regions. You're never going to have 4 and 2 be shaded or 4 and 3 be shaded. It's only going to be this part or this part, but never both of those parts. Quick reminder, if our inequality uses less than or greater than, we're going to use a dashed line, and if we have greater than or equal to or less than or equal to, our line is going to be solid. So let's go ahead and get started with our two inequalities. This is over here. I'm going to show you at the end how you're going to do this. on your Blackboard quiz at the end of this. So let's go ahead and get started. Looking at this top one, I sort of have slope-intercept form, except for instead of having an equal sign, I have a less than. Keep in mind, this is going to be a dashed line. Okay, so because it's in the same basic format, I can start out with my y-intercept at positive 2, and my slope is rise over run, 1 over 2. So I'm going to go up 1 and to the right 2, up 1 to the right 2, and just so that I can make certain that my line is graphed accurately, I'm going to say, hey, listen, 1 divided by 2 is the exact same thing as negative 1 divided by negative 2. Divided by a positive is positive. A negative divided by a negative is positive. So I can also go down 1 to the left 2, down 1 to the left 2. Okay, so let's grab our ruler, and this ruler is too long for my needs. Okay, that's going to be a little bit easier for me to deal with. All right. Now, keep in mind that this is a less than, so my line has to be dashed. My line will go from one side of the graph to the other, and it needs to be dashed. I need to have arrowheads on either end. All right, next up, I need to choose a test point. If my line does not go through the origin, I'm going to use the origin as my test point. 0, 0 is always going to be the easiest math. So I'm going to plug in 0 for x and 0 for y. So in this equation, y is less than 1/2 x plus 2. I'm going to plug in 0 for y, 0 for x. And no matter how nasty this fraction is, nasty fraction times 0 is 0, which is exactly why we choose that. Okay, 0 is less than 0 plus 2 is 2. Is this true? Is 0 less than 2? Yes, it is. So because of that, we are going to, so this right here was true, so we're going to shade below this line. And I'm not going to do anything just yet because my solution set is only the part that's true for both lines. So I don't want to go hog wild here because I want to make certain that my solution set is super apparent. All right, let's work on this other line. Y is less than or equal to negative 2x minus 3. Y-intercept of negative 3, come down here. This is going to be a solid line. My slope is negative 2. Because I've got a whole number, I'm going to put it over 1. So I have a rise of negative 2 and a run to the right of 1. Well, this negative 2 over 1 is the exact same thing as 2 over negative 1. So I can go up 2 and to the left 1, up 2 to the left 1. Now listen, it looks like our graph is going to cross right here, but I actually don't care because my solution set is not the point where these two lines cross. It's all the points that are true for both of these inequalities. So you got to keep that in mind. We're not looking for a singular point. We're looking for the solution set that's created. Whoopsie daisy. There we go. This is less than or equal to, so this is going to be a solid line. And we need to have arrowheads at either end. We're also going to test 0, 0 for this one because it's pretty math. 0 is less than or equal to negative 2 times 0 minus 3. 0 is less than 0 minus 3 is negative 3. Is that a true story? Is 0 less than negative 3? Honestly, I think if you owe somebody $3, you have even less money than $0. So 0, 0 is not part of our solution set, which means nothing on this side of this purple line is part of our solution set. So our solution set for the purple line is all the stuff to the left of it. Well, what's the part that works for both lines? The part that works for both lines, and I don't have the ability to shade lightly for this. You would just hold your pencil very, very lightly. I don't want you using a highlighter just because I do on the smartboard. I don't have the same ability that you have with paper. But the shaded or the part that we're going to finally shade is the stuff that works for both. So anything that is both below the blue line and to the left of the purple line. So everything over here. And I will say this, when you're shading, very, very light. You're not coloring in, you're not doing it as dark as the lines. The other thing is you want to leave a little bit of gap. It's important for us to be able to see, is this line dotted, or solid. So this is my final solution set for this line. Okay, so before I let you go, I want to talk about what you're going to be doing on the um, Blackboard quiz. So I'm going to come over here and just bear with me for 1 second while I tidy this up a little bit. Okay, so when you take the Blackboard quiz for this problem, which is the last one, we talked about how there are 4 regions to the 2 intersecting lines. So what you're going to do is you've got a blank graph on the sheet that you were able to print out before you watch this video. And you can use that graph for graphing the 2 lines that are given to you on the Blackboard quiz. Go ahead and graph them just as I did, shade them just as I did. And when you're done, you're going to see that one of your areas is the shaded region. So this is what we just had. So I would write that D is the answer. So the letter that corresponds to the region that's shaded on your paper is going to be the final answer for this problem, on the last problem on the quiz. Keep in mind that if you get stumped at any point on the quiz, you can come back and rewatch portions of the video to make certain that you understand. You need to take the quiz until you pass, so if you get something wrong, come back and rewatch. Figure it out. Don't just wing it again. All right, good luck and thank you for watching.